Hello, my name is Madhu, and our project is TrafficAI. According to the Federal Highway Administration, there are an average of 6 million car accidents and 36,000 car accident deaths in the United States annually. 25% of these deaths caused could have been prevented had the police been called earlier. However, the average time to call the police is between 3 to 5 minutes. But what if we could eliminate this delay entirely? We present to you TrafficAI, an instant car crash detection program with functionality to alert the authorities. We use machine learning to train a model to identify car crashes from a sequence of CCTV footage frames and deploy it onto a web application. The web app visually and audibly alerts the security guard when there's a car crash.
The dataset we used was the CADP car crash video dataset. And for pre-processing, we first used the annotations on the dataset to separate the crash frames videos from the non-crash frames. We are a class-separated dataset of images. This was necessary so we could train the CNN and learn to recognize a crash.
And after pre-processing all the images, we used the CNN LSTM model architecture to analyze the spatial temporal features of our input sequence over time. To do this, we took each of the end frames in the input sequence, put it through a pre-trained ResNet, the latest and greatest convolutional neural network variant, and this gave us n feature vectors, which represent the most important information about each frame. We then send these feature vectors, or spatial features, to an LSTM, a long short-term memory network, which analyzes data over time. The LSTM gives us a single number between 0 and 1, indicating crash or no crash. So again, in summary, we have our n input frames, we get spatial information from the ResNet, temporal information from the LSTM, and the composition of these two gives us our final classification. And now for our results. So here's our training logs and confusion matrix. We obtained a final accuracy of a little bit over 83% on our training and validation sets, but on our testing set, the average accuracy dropped to around 78%. And although these numbers are a little low, this is actually a little misleading because the model doesn't actually have to be 100% accurate in exactly where the crash starts and ends. What we really care about is that the model detects crashes sometime in that range. So in this graph, you can see the frame number versus likelihood that a crash occurred in a single video, where blue is ground truth that we got from the annotations.json file, and orange is a model's prediction. And the model doesn't exactly follow the blue line for every frame, so the accuracy isn't exactly 100%, but it still detects all instances of car crashes that occurred in this video, and we got similar results for most videos.
This is a demo of TrafficAI. Our prototype displays live feeds to security guards along with their location so that the security guards know where to go when there is an accident. Currently, since there is no accident, no warning is being displayed. But once an accident is detected by our machine learning model, a warning is sent out through an audio cue, and security guards can then alert the authorities. Extensions for TrafficAI include integrating a database that captures data for each accident, including the time and location, and then providing this data to analysts so that they can look for patterns and further reduce the amount of accidents and deaths. Another extension that can be made is continuous machine learning. So at the end of each day, the model can go through the points of the day where it classified the footage as an accident occurring and confirm it manually with users. Using this user input, the model now has further data that it can train on that has been user labeled, and it can train itself to be smarter in future car crashes. Thank you.